Hello everyone. Hello. How is it going? Uh Good Saturday. Chill one. Sorry, that's a loop. My bad. Still learning stuff, man. I'm still learning stuff. Still learning how to do this thing. Okay, I keep forgetting here and there. Welcome everyone. Uh I hope everyone's having a good weekend. A very chill weekend. So yeah, I started streaming again, and the goal of today is to keep continuing working on the Blind75 problem set. Yesterday we completed 21 problems. Today I don't have any such goal of how many problems I want to do. I started streaming early so that I can keep continuing for a little bit long. But let's see. Again, schedules are a little bit messed up, so we have to think how to have a proper schedule. But nonetheless, yeah, if you tuned in, thank you so much. If you like what I'm doing here, do give a thumbs up. And yeah, please feel free to drop a hi in the chat and we can talk. Thank you. We can get started. And we'll keep continuing with sum of two integers from yesterday. Just let me know if the music is too loud. I hope the music is not too loud. My voice is clear. Okay. Cool. So we'll keep continuing working on sum of two integers. Okay. So yesterday, this is where we signed off, and we couldn't do it. So we can keep thinking in terms of bits. That is what I exactly started yesterday. We can keep continuing in thinking in terms of bits. So what I would like to do is I would like to keep continuing on working on 3 plus minus 2. Okay. So integer to string, my bad. Integer to binary string minus 2. Yeah. So we have this, and for this we have 1 but I am not quite sure how to do a left pad. So let's quickly do Java string left pad with a character. I mean, yeah, but I don't want to do that. I really don't want to do that. Okay, you're telling me I have to do this using like Java string doesn't have a left pad. String pad Java 24. Really? That is very stupid, because why won't you have a... Okay. What did you do? You said this is not what I want. I want to pad stuff. Okay. Let's quickly go here and ask ChatGPT, right? Binary string minus 2. Pad the string len. Okay. Could have done that by hand, but why when you can have ChatGPT do it for you? Okay. So in here, if you look at this, so 0 plus 0 is usually, not usually, it's basically 0. So we have to add three we have to add three things here because I have to start also with a carry. Right, so here carry is 0. So this so this here is 1. Sorry, this here is 1. Sorry, this here is 1, and you have this thing as 0. Then you move forward here. This would be 0 and carry 1. 1 plus 1 0 and carry 1, so it would go here and everything would be 0. So I think it's working. I think it's working. Yeah, that is probably how I have to go forward with. Okay, so this is the approach I'm gonna take, and I think this is how I solved it before also. I don't quite remember, which is why it's very important to have notes so that I can look up. Okay, sum of numbers. Okay, so sorry, we can convert it into string. But I don't want to convert it into string. And specifically, so what I am gonna do is I'm gonna do a helper function. Okay, private. Only problem is Java doesn't let me return two things. Java does not let me return two things. So I'm just gonna write sum. Okay, int a, int b, int c. If a is 0 and b is 0 and c is 0, turn. Can I just do it like this? No, I have to say int. Okay, 1 2. How many lines are so let's just keep doing. This is 1, this is 1, this is 1, this is 1. Okay, then in here let's make this as 1. This will always be 1. This is 1, this is 0, this is 1, and we could have written an if else, but yeah. Okay, so if all are zeros, it is 0. If there's 1 1, so you have sum as 1. In here also is the same thing, so you have 2 this thing, so the sum is hey Wolfication. I'm sorry if I'm pronouncing your name wrong. Wolfication. That's a very, very cool name, I would say. That's a cool name. How you doing, man? Thank you. Welcome to the stream. How you doing? Thanks. Thanks for joining. How's your weekend going? Okay, so you have 2 of those, which means like the above one. So your sum is. Wait, did I mess it up? I did mess it up because yeah, carry is 1. Okay, so then you have this thing. So you have a single 1. Then you have 2. So your carry should be 1. Then you again have 2 here. So your carry should be 1. Wolfication. Looking at the name, I have a feeling I know who you are, but yeah, I cannot be sure. But looking at the name, it feels like, because I know a guy who would come up with these sort of names. I definitely know a guy. And if you think I got it right, I think you can already send a private text to me that yeah, I'm right. But yeah, how's your weekend going? I hope your Saturday is going good. Okay, coming here, what exactly is happening? Yes, you know me. I think I know you. I'm gonna later text you and confirm, man. Okay, cool. So you have 1-1, okay? That's pretty much it. And this ass is complaining because the compiler cannot figure out that, hey, I did everything exhaustive, right? So probably we can use the switch case pattern, but I don't think so we can do pattern matching here in Java yet. Uh, Not quite sure. So let me quickly ask uh, Copilot. With Java 24, can I do pattern matching? Which is expression. Okay, messed up the formatting. Java 21, blah 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 blah. I mean, I understand we can do list of, but I do not want to structure it a list. I don't want to structure a list. I just want to have destructured pattern matching. Can you do that or not? Suppose you cannot do it. I suppose you cannot do it, but this kind of looks cool. So I'm going to copy paste this code. Okay. I'm going to copy paste this code in here. This definitely has implications of your. It's not 24. It's 24. What is it complaining about? Constant expression pattern or null is required. Cannot resolve off. You cannot understand what list of is. You can understand here, but you cannot understand here. Okay, so ChatGPT hallucinated. Okay. So here I'm just gonna say in illegal argument exception, invalidating. I'm just gonna say that. Okay. Now the compiler is gonna shut. So what we're gonna do here is that if A is 0, you return B, and if B is 0, you return A. Okay. Second thing, you have a constant time iteration here because of the fact that your it's 32 bits, right? It's integer, so it's 32 bits. So I can simply say for int I equals 0, I less than 32, I plus plus. Int carry is 0. So we start with 0 because like the very first we don't have carry, right? Sorry. So what we're gonna do here is that we're gonna say we're gonna first extract out A. So A will be nothing. Damn it, we call it A here. I mean, who says I cannot rename it like this, right? So X, call it X. So X would be something where I'm gonna say A and 1. But before that, I gotta shift it, right? I don't want to change the input. So right shift, and I want a signed right shift, right? So if I have the signed bit, I want it to come. Also, I don't think it matters because I always take the last bit, so it really doesn't matter. Okay. And then Y will be B. So if you have this part in here, what you can simply do is sum X, Y, carry. And again, we cannot destructure it, so we have to say sometimes I cannot type. Okay, so carry would be this, and the bit would be 0. Sorry. Now we gotta find the sum. So what you have to do in here is we gotta set that position. We have to set that particular position by left shift, right? We have to left shift it by so many bits and do it. So as an example, I shifted on the right by 31, so I have to right shift it by this many number of bits if I'm not wrong, or it's 31 minus I. So here, if I want to set this particular bit, I right shift it by 1. Now I gotta left shift it by, so somewhere here the bit would be this. So I gotta left shift it by 1 position. I don't think I have to do that. Yeah, I don't have to do that. So I take the bit and I left shift it by this, and I say this is this, and I reassign the guy and return sum. I think that should be it. Let's just see, that should be it. Okay. Last solution. Okay, that got accepted. Submit and see. That's pretty cool. I hope ChatGPT didn't lose the context, right? I hope ChatGPT didn't lose the context and can actually tell me what's happening. Okay, awesome. Manually add bits using full adder logic. I didn't know it's called a full adder. What is a full adder? The basic completes the sum of 3 bits. Okay. Adder versus full adder logic gates. The half adder is a combinational unit that adds 2 of the 1-bit binary digits, carries the sum and okay. The full adder is a type of combinational logic that adds 3 of the okay. Okay, so you're telling me if I just take 2 bits, it's a half adder, and if I take 3 bits, full adder. What if I had 4 bits? If I'm adding 4 numbers, what is it called? Full adders can be implemented using 2 half adders and an OR gate, or directly an AND or XOR gate. Okay, that is interesting. I could have done that using 2 half adders and an OR gate, or directly using AND or XOR gate. So let's actually learn about it first, okay? Because it handles carry, unlike the half adder. Can we create write me a code which takes 3 numbers, uses half adder logic, generates the adder? I hope it can make sense of my question. So I want to understand this particular part in here. The full adders can be implemented using 2 half adders. The user an XOR gate for the sum and an AND gate for the carry. Okay, so if you XOR 3 numbers, you get the sum. If you AND 3 of those, you get the carry. Is that what you're saying? The half adder is okay. Okay, so the half adder is the sum is basically XOR, and then the carry is AND. Okay, and then you can simply say half adder of this, half adder of this. I might be creating a couple of intermittent arrays, but those would be on the stack. Those would not be on the stack. Sorry, those still would be destroyed immediately going out of scope if the GC runs. Right. So you have 2 half adders, and what you can simply say is that you take the half adder 1 and you do A and B, and whatever you got, you take that particular sum and you do another half adder with C int carry. The sum would be whatever your output came, and your carry would be the output of the first half adder or output of the second adder. Okay. I think that is worth writing down because I was not aware of that. So in here, maybe I can create a folder called bit I don't want to do it like that. With operations and adders. Half adder, adding 2 bits, some carry. So a quick note here is that x XOR y, sum is this, carry is x or y. Full adder is saying take half adder, x, y. So here we need some sort of thing here. So you take these two and you would get back an SN carry, let's say. This is S1 carry one, let's just say that. Okay. And then what you can do is, why is the tabbing so weird here? Why can't you just simply tab? Okay, we'll do that later on. Okay. Then you have S2 and carry 2. It's saying you again do a half adder. You take S1 and you take Z. Okay. Then you say sum should be equal to. Okay, I forgot. Sum should be equal to whatever you got here, S2. And then carry should be equal to C1 or C2. That's what you're saying? Yeah. Or of both carries. That is pretty interesting. And let's actually implement that in this particular thing. So this is something new that I learned. It's quite good. Okay, now we have built a full ladder using. With Java, we cannot return multiple values. Only possible way is array. So what's the memory footprint implications? Even though if numeral and dies when out of scope, seems like a lot of work for GC. Clean up intermediate states when compared what's the benefit? I want to understand what is this button, blah 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 blah. Give me the implications, buddy. JVM optimizations like scalar replacement may avoid some of this, but not guaranteed, especially in method boundaries. Okay. Does some method pre-computed lookup, zero allocations, branch heavy, but okay, that is true. There can be branch prediction misses because of the fact that your CPU instructions might not go down that path. Right, so zero allocations, branch heavy, and JVM can optimize this very well, like compile to a jump table. Okay, extremely easy to find. Full adder with 2 heap allocations per call. Yep, much heavier for tight loops. So in tight loops, allocation of tiny arrays may be elided. What the dude, use English, which omitted. Just say omitted. Okay, tiny arrays may be a little bit just skip analysis of scalar replacement. But in general use, or the method is polymorphic, not inline, these tiny arrays do live in the heap and GC must track and clean them. JVM is smart, but it's not free. Avoid returning object wrappers like this just to simulate. Yes, instead use bit packing. Aha! This is quite an interesting point. This is where real engineering comes, and I didn't think of it. And we can even think in terms of actually returning short and not um, hmm. So I can take the last bit and you know use it as sum. I can take the second last bit and use it as carry. Okay. Okay. I need to take a quick 5-minute break. Uh, yeah, I will be back soon. Meanwhile, please enjoy some music. Thank you. I'll be back. Okay, we are back. We are back. Let's keep continuing to work on this thing. So yeah, I want to implement this with full adder and not this part, because this part also has branches, right? So there can be branch prediction misses and things like that. I feel if we do the full adder and half adder, and specifically with bit packing, what we are talking about, no GC pressure, where on earth you say bit packing? Somewhere you mentioned bit packing. Where on earth did you mention it? Yeah, so use bit packing, right? So if you do this part, it kind of becomes like you can even return back integers, right? So this becomes a very easy solution. Let's try and implement it. So private int half adder. So you have int a, int b, and what you're going to do is int sum is a or b, and carry is or. Is that right? Or is and? Sorry, that is correct. Okay. So now what I'm going to do is you have sum, which is again going to be a bit. So I'm going to say sum or carry left shift by 1. Now, if you look at this part, where if you have, where's X carry? If I have 1 and 0, this is a sum, this is this. So 1, I take this bit and I left shift. So either like this particular, so out of 32 bits, this particular bit is the sum. This particular bit is the carry. Now that I would say is a really good way of actually solving this problem, and not just solving it for sake of Leetcode, right? This is where real engineering comes in, because if you might be doing some kind of crypto, or if you might be doing some kind of crypto algorithms, I feel this is where you actually cut down on memory. And this is more like bit fields, right? You can consider this entire thing as a bit field, and you just need these two. That's nice. Okay. So now you have full adder and int a, int b, and int c. So here, first I'm going to call half adder with a and b. Sorry. And because it's held adder, okay, it's half adder. I'm gonna lower it a little bit, hope that's okay. Okay, so let's call it result 0. Okay, we're calling it result 0 fine. Int s0 should be r0 and 1, and c0 should be, I just move it by 1 and say the same. And here I don't have to move it by signed bits, because the fact it's moving 1, I would never move 32, right? So also it really doesn't matter. I'm just taking the last bit. I'm not taking into consideration what kind of result I'm getting when I'm doing the shift, right? So we can do a signed shift without an issue. I mean, we can do an unsigned shift without an issue. Okay. So now you have this part. So int r1 is half adder. We've got to take sum 0 and c, right? Int sum should be r1 and 1, and then int carry would be, let's call it c1. Sorry. So you take r1 and you right shift it by 1, and you take the last bit. Then you say that, sum, my bad, sum or carry left shifted by, sorry, int carry should be equal to c0 or c1. Was that it? Yeah, or c. Okay. Also, I want to rename these things to 2, just to make it correct with my, aligned with my notes. Okay, and this can be called as 1, and this can be called as s1, and this can be called as r1. Okay, now what you can do is sum or carry is saying sum equals this, return the sum. Okay. Okay, cool. So you have this, What I'm gonna do is full adder, and I'm gonna get a result back. Int s should be result and 1. Let's call it sum bit. And carry bit should be result, right shift by 1. Sum bit. And that should be it, I think. I hope I didn't miss anything. So let's quickly actually check if this works. So solution. Let's see if this works. Wrong answer. Awesome. Why is it wrong answer? For this, why would that be a wrong answer? Yeah, no, that is not it. That is kind of weird. Where did I mess it up? Let's quickly see. So you shift them by 1. You shift them by I, and you take the last one. Right shift by 1 here. Somehow it's coming as negative. Is it the same for the other one? No. Okay, so the logic itself is wrong. Okay, let's quickly go to the logic. This part should be correct. The sum is this. Okay, so you say sum or carry left shifted by 1, and you return the value. Okay, in the full adder, first you do a half adder on A and B. Then you say the sum is basically the last bit, and let's just do this, and you take C1 as the second bit. I mean, the right hand side is the first bit, and then this is the second bit, right? Then you take into consideration the R2 is taking the sum of 1 and the carry itself, which is what I have written down, right? Yeah, and that gives you back the actual sum. So yes, this actually gave you back the sum. Okay, and you right shift it by 1 bit and you take that particular bit. That is basically your carry 2, and so carry would be C1's mistake. And then you try to do the same thing, whatever you have done there, and you return the sum. What I don't understand is why exactly it's an issue. Okay, time I guess to this is not working. I think I messed up the address. Can you tell me what's the issue? Feels like I messed up somewhere here. Something off in a half error. Let's walk you through. Sum is this, but in your code you wrote carry is, so I wrote it wrong in here. It's this. Okay. Maybe that is the only thing that we have to change. Window. Okay. Awesome. But did it actually... okay. There is literally no difference in here. I mean, again, we shouldn't be going with like O notations. Hmm. This is more of a branched solution, so I think this has to be faster. And we can actually look into that later on. Okay, so I suppose I want to quickly take a note because I want to do this later on. And why didn't it open up? It did open up. So let's just add it here. Right. Leetcode, add two numbers. If else versus adders and bit back. Perf check. I suppose we can actually look into this part later on. Okay. But yeah, for now, I think we are good. So that was quite interesting and something new to learn. So just to have a recap or summarization. So just to give a summarization, what is happening here is that you have a full adder, you have a half adder. So half adders can basically take in 2 bits and give you the sum and the carry. And the sum and the carry can be like two XORs. XOR will give you sum and the carry would be and then you take the half adder, you take the sum and the carry for the first two, then you take that sum and you half adder it with the carry. Okay, so then you basically get the sum, and if you take in the two carries, the carry bits from both the operations, you basically have to do an OR operation to say that what exactly is the total carry. That is what it is. Similar 2-bit addition, half adder is this, build full adder. Yeah. Symbol results and all of that. Yeah. Okay. Voids plus GC. Avoids memory allocation in GC. Safe works for all sign-in. Sorry. Yeah, cool. Okay. So pretty good learning. Good one. I actually solved it before, but I never really looked into it. Actually, it's kind of helpful, right? Okay, so valid anagram. Let's move on to the next problem. Given two strings s and t, return true if t is an anagram of s and return false otherwise. So valid anagram. This is a very easy problem. Given two strings s and t, return true if t is an anagram of s. Anagram is nothing but everything has is a phrase reformed by arranging the letters using the original letters exactly once. Okay, and false otherwise. So if two of them are anagram, you can say, okay, this is true. If not, this is false. Basically, every one of the characters has to be the same, and every one of the sorry, every one of the character count, the frequency has to be the same. So as an example, a is 3 times here, a is 3 times here. It doesn't matter where it comes in the string, it has to be the same. Okay, this is basically it. Okay, What if the input contains Unicode characters? How would you adapt your solution to such a case? So here's one interesting thing. It's saying S and T consist of lowercase characters, and I am working only with this, only lowercase characters. So to keep account, the usual thing that you do is a map. But in here, we can actually take use of an array, a frequency array, right? But if the input contains Unicode characters, we cannot then work with characters anymore. Like an array, we have to go a huge number of array, right? So total code points for this thing, right? Yeah. Oh, this is still not huge. This is still not huge, so I guess we can do it. Uh-huh. 154k, 155k. So it's not that huge. My cat is falling out. He has nothing to do with me. Went by. He only comes to me when if I give him food. That's all. Oh, he's actually at my leg. Oh, he's gone now. Okay. Let's actually do this valid anagram. If s dot awesome, it actually finished it off, right? If they are not equal, okay. So frequency is this. So let's call it frequency array. For int character ch as this thing. So what we can do is we can take this and we can subtract a from it. Convert that to int. I don't think we have to convert that. So you go to frequency array and you do this. That's pretty much it. So I'm capturing what is the frequency. Then here, if this thing is 0, turn false. Otherwise, just do that. Turn true. And that should be it. So in here, if the character was never present, this would have been obviously 0. So it already fails, fail fast. If the character has been the same and you already, like the count is mismatched, so in your T, in your S, in your input string, you have used almost 2 A's, and on the out, like the second string, you have used 3 A's. Okay, sorry, I'm a little bit distracted, but yeah, okay. We'll keep continuing. Okay, so yeah, this problem should be working fine. Let's quickly see last solution. Hopefully I didn't mess up anything and this works. Okay. And meanwhile, okay, that's not a good sign. Why is it doing like that? Is it gonna fail? Is it gonna fail? Okay, that was, I suppose, just this thing. So interface, I want to look at a solution where I use map. Yep, I'm pretty sure I use map here. Yeah, so I use a map, and if you use a map, it's a heavier chunk of object. Even though integer array is an object, this here is just a wrapper on top of arrays, right? Map is a wrapper on top of arrays, so that is why this abstraction would be more costly than this one. Okay, so this is why this is a little bit slower and this is again fast. Okay, cool. I think we did 3 problems. Let's try to get at least two. How long have I been streaming? Why does it tell me the time how long I've been streaming? Okay, I know exactly where to look for it. Yeah, I've been already streaming for almost an hour. Okay, we'll try to have a little bit more time before we go for dinner. Okay. Okay, product of array except self. So given an integer array nums, return an array answer which says that answer I is equal to the product of all the elements of nums except nums1. The product of any prefix or suffix is guaranteed to fit in. Okay. So this is quite important because it won't overflow. Okay, so if it overflows, then it would wrap around and all of that because we don't have unsigned in here. Even with unsigned ins, with multiplication, you can easily go overboard. But it clearly says that it's guaranteed to fit in a 32-bit integer. Okay, so you must write an algorithm that runs in O of n time and without using the division operation. I kind of hate these problems where they say do not use these operators. But then as and when you try and figure things out, it becomes kind of interesting. And this is a very interesting problem here. Okay. So the usual way, if I just sum it out without the division operator and all of that, is that if you're trying to get the product except this guy, you would just iterate over the array, and you would not consider this element when you're taking the product, right? That's basically the answer. So if you have you would have an outer loop, which says 0 to n, and you would have an inner loop 0 to n, I mean n minus 1, let's just say. Okay, so 0 to n minus 1, and you would say that, okay, like if this is I and this is j, I equal j, just skip. Okay, just skip over. The problem here is this is an n-square solution, and looking at the constant, I mean, it clearly tells you to have to write in O of n, and then there's 10.5, so you have to go towards an n log n solution, right? Yesterday I think I already showed this useful thing. So yeah, if it's less than 10.6, it's like n log n. Okay, again, I don't think it's a hard and fast rule. You can easily have to, you can do an n-square solution for 10 to the power 6 if you have a huge giant computer and you don't care. But or like, it's more of a standard for computer programming, I would say. For anything production, I don't see how this would work. You have to do benchmarks. Anyways, that's probably another discussion. So coming back to the problem statement, right? In here, you have so if you have to do an n solution or of n solution, what can be a better solution than this? One of the solution would be I go from 0 to n and I take the product of all the numbers. So in here it's 12, 24, and then I iterate over every one of them. So your loop is ended, so it's an O of n loop, and then you iterate over every one of them and you say, okay, it has to be the product divided by array of 5. In here it would be 24, in here it would be 12, right? And that makes sense, right? And that makes sense because you have taken, so it is mainly like, if I say what is the entire sum except that element, you just do an entire sum and you have to just subtract that element to get the entire sum of the array except that particular element, right? So this is how the product thing would also work. Okay, you of course have to do null zero checks here, otherwise you would have, I think it's arithmetic exception in Java, but yeah, you have issues with zero. So if you have a 0, you have to make sure you do the multiplication carefully so you do not actually end up the product being 0, and when you have a 0, you do not divide it by 0. Okay. All right. Anyways, so now the point here is that this also would become a little bit difficult. Just to have a quick iteration, that would also become a little bit difficult because you have to keep a track of if there's 1 0, if there's 2 zeros, right? Because you cannot always say if the product is going to be 0. So ideally speaking, if there is a single 0, if you're here, will the product be 24 or will the product be 0? Because if there's another 0, you cannot be product 24. It has to be 0. So yeah, these kind of edge cases are there with zeros here. Okay. But nonetheless, we cannot do it here because we cannot use a division operator. Okay. So what can be a viable solution? Okay. So let's think in this way, that what is the product of the array except this element? It is a product of these elements. It's a product of these elements. For this guy, there is nothing on the left, but it's basically the product on the right hand side, the product on the left hand side, right? That's how it is. Is there a way we can calculate that? I think yes. For every element, this can be the suffix product, this can be the prefix product, pp. Okay, so it can be pp. So the question here is that how do you do it, right? So we are gonna go with some kind of trade-off. Since we cannot do division operator, and though this gives an overfit solution, this would really be edge casey. But anyways, nonetheless, since your what is that called? Like, you cannot do the division operator, you have to, try and go with a different solution, which we are right now talking. So what is the suffix here? Suffix is 1. Well, there's nothing here, so I have to consider suffix as 1 because otherwise it would be like, I cannot take 0. Otherwise every product would be 0, right? Because if I just switch here, what is a suffix? Whatever is the suffix of this guy into this element. The suffix for 3, the suffix at an element I is equal to I plus 1 into array of I plus 1. And the prefix would exactly be the same, except it would be I minus 1 and I minus 1. Okay? And then at every given point of it, I can just multiply the suffix and the prefix. So usually how I do it is, I create a single array. So this is 1, 1, 1, 1. We assign every one of them, like 1 to every one of them. The second thing that we do here is that we are going to say that sorry, we are going to say the suffix sum, the prefix product is 1. Okay, the prefix product is 1 and the suffix product is also 1. We're going to pre-compute this and this. Right. We're going to pre-compute this and this. Okay, so here what is the sorry, what, so we can start from here. At position I, the prefix sum is prefix into array of 0 or I minus 1, and whatever answer I get, I'm going to multiply it in here. My bad, I'm going to multiply it in here. This is 1. Okay, and like this I would go here. The reason why I start from 1 is because on this side the prefix is always 1. Okay, the prefix is always 1. Similar thing I'm going to do for the suffix, and I'm going to take a pointer from here, my bad, and I'm going to go to this. And if I keep on multiplying, this is where I would say that, okay, it's suffix into prefix. It's suffix into prefix. Okay, and I multiply it with whatever this value is in this product. Okay, so I can take 2 pointers and start, calculating the suffix product and the prefix product at the same time, and keep multiplying in those positions. And since I always started with 1 and some multiplication, it would take care of it. Okay? So this is how the solution is. I hope I was clear. If not, let me know. We can talk about it again. But yeah, I think let's load it up. Product of array except self. Product of array except self. Okay. Int suffix product is 1. Prefix product is also 1. So let's actually do that. And then int left is 1, right is const of left minus 1, minus 2. For let's just say while left is less than const of length. Sorry. What is gonna be the prefix product? The prefix product is gonna be minus 1. And products of left is gonna be multiplied with that. And I'm gonna move the pointer. I can also do the same thing with right, but I can simply, do it in here, because I'll come to that. Because by the time, like, I mean, here I can add something for right, but not. So here I can continue working with from here. From here, if I go till here, in the same time, this would come from here to here. So it will always be within the bounds, okay? Okay, meanwhile, how's it going for everyone? How's your weekend going? How is Saturday treating you? Okay, this works fine. So let's quickly go over and get the notes. And look at that. In 1 hour, we have solved 4 problems. Actually, 3 problems, I think, right? I'm not doing a kit track, so it's kind of difficult to say which problems we solved. But I think we solved 3 problems. Sorry, 1, 2, and 3. I would like to solve 2 more problems. But it's already 10:30. Okay, I guess I'm gonna go off now. This is quite good progress. But since I want to continue grinding on a Saturday, what I'll do is if I can come online, I would be coming online in the night or maybe tomorrow. So, yeah. I am actually going to stop streaming now. We'll close the stream. And I'll grind in the night if I can. Not sure if I'm going to stream. But yeah, thank you so much for tuning, everyone. And have a good Saturday. And I hope you had a good time and this was more informative. And thank you for joining. Thank you.